All right, here we go with our second screencast on water, continuation of chapter 3.2. Water, still awesome. So we already talked about the properties of water, cohesion and adhesion and surface tension and polarity and hydrogen bonding. So now we're going to move on to the rest of the list, which the next property of water is moderation of temperature. So water is really good at absorbing heat from the warmer air, which makes it cooler. And it releases stored heat into the air if it's cooler. And this is, of course, as you know, because of specific heat, but we'll get to that in a minute. Water can absorb a very large amount of heat with only a very slight change in its own temperature. So it's a very good kind of heat energy storage substance. So before we move on to why it's good, which is, again, specific heat, I just want to clarify, make sure we know about heat and temperature. Okay, kinetic energy is the energy of motion. More chemistry review. Heat is a measure of the total amount of kinetic energy due to the motion of molecules. And as we know, all molecules are moving at all times, even like the whatever device you're watching this on right now, your iPhone, your iPad, your laptop, it's moving. Every molecule of that pad is moving, okay? And it moves until it gets to what temperature? Yes, absolute zero, perfect. And then it doesn't. Okay, and then, which is a good segue to temperature. Temperature measures the average kinetic energy or the average motion of the molecules. So when molecules are moving slower, it's at a lower temperature. When molecules are moving faster, it's at a higher temperature. Okay, so quick review there. So let's move on to specific heat. Specific heat of the substance, as we know from chemistry, is the amount of heat that must be absorbed or lost for 1 gram of that substance to change its temperature by 1 degree Celsius. Okay, very dry. But what that means is the amount of heat energy that a molecule or a substance can either take on or release before it changes its temperature. The specific heat of water is 1 calorie per gram per degree Celsius, which is huge. That is a huge amount of heat energy. Okay, and I'm sure you guys did some calculations last year on how this works. But because of that, because the high specific heat of water, it really resists changing its temperature. You can put a lot, anybody who's like tried to wait for the pot to boil to make your mac and cheese, it takes a lot of energy to change the temperature of water. Okay, and that's because of its high specific heat. High specific heat can, of course, be traced to what? Hydrogen bonds, because of the polar nature of water. Okay, everything is about the hydrogen bonds. Okay, so when hydrogen bonds break, heat is absorbed. When hydrogen bonds form, heat is released. Okay, because of this, the high specific heat of water minimizes temperature fluctuations to within the limits that permit life. So we have so much water on this planet, and that's what keeps it kind of at a relatively narrow range of temperature. I mean, we don't think of it as a narrow range of temperature, but it really is a relatively narrow range of temperature, so that we can all live comfortably. All right, and this just looks at how water moderates temperature. You'll notice we got a little West Coast going on here, LA, San Diego, my former home. The temperatures on the coast are always cooler because water will remove the heat from air when it gets too hot, so it's cooler in the summer, and it's also warmer in the winter because water will release heat into the cool air to keep it warm. As you go in, oh, you can't see San Bernardino here, but San Bernardino, there's some Little League ballparks there that we've played at. Palm Springs, most people have heard of. It is hot. No water anywhere near there. This is the desert. Okay. All right. So moderation of temperature. And next we're going to look at evaporative cooling. Again, more chemistry. So evaporation, transformation of substance from a liquid to a gas, high heat of vaporization of water as well, causes a lot of energy to be released when those hydrogen bonds break. Okay, so as a liquid evaporates, the molecules that are hottest, that are at the highest temperature, that are moving the fastest, move fast enough to break the hydrogen bonds, and they leave the cooler molecules behind. So the hottest molecules leave, they leave the cooler molecules behind, and this is what we call evaporative cooling. Okay, and evaporative cooling is what helps to stabilize temperatures in both organisms and in bodies of water, right? So when you get out of the water, or when you sweat, sweat is a way to cool the body down because it puts liquid on the surface. When that liquid evaporates off, it leaves cooler liquid behind. Okay. Another property of water, ice floats. Okay. Most solids, most solid forms of a substance are more dense than the liquid form. Okay. Because the molecules are moving slower, packed tighter together. Water is a little bit different. And why is it different? Why would water be different? Oh, because of hydrogen bonds. Bum, ba-da-bum. The hydrogen bonds in water are so strong, they kind of hold the water molecules like at arm's length. You can't see my arms right now, but they are holding out like I'm holding back some other water molecules. Okay. And this leaves air pockets, leaves space between the molecules, and it makes ice less dense. Okay, so water reaches its greatest density at 4 degrees Celsius, which means it doesn't freeze at that point, and that's why the water at the bottom, then it sinks to the bottom, and life can, the fishies can live there even if there's ice on the top of the surface. Okay, if ice sank, all bodies of water would freeze solid, and life would not be possible on Earth. All right. Oh, and here's a little picture of how the hydrogen bonds work. They hold the molecules apart, and they allow for some air pockets. Then ice can float, and then liquid water is a little less dense because the water's molecules are moving faster. Hydrogen bonds are breaking and reforming, and so they can slide closer to each other. All right. So water is also Is it the last property of water? Maybe. The solvent of life. Okay. So you guys here, pause it and read that stuff. You guys know all that. Okay. So water is a very versatile solvent due to what property? Why is water so awesome? Oh, that's right. Hydrogen bonds, because of its polarity. So polar substances, because they are charged, can bond to other polar substances, and this can facilitate things kind of dissolving in water. Okay, when an ionic compound dissolved in water, it's surrounded by this sphere of water called the hydration shell, and we have a picture on the next page. Okay, so we have some sodium chloride, our good friend salt. It dissociates into sodium ions and chlorine ions. The chlorine ions are negatively charged. They'll be attracted to the hydrogen end. The sodium ions are positively charged. They'll be attracted to the negative oxygen end, and everybody's happy. And all the charges are protected. Everybody's bound together, and we're dissolved. Okay. Water can also dissolve compounds made of non-ionic compounds that can dissolve molecular compounds, as long as it contains polar molecules. Okay, so large polar molecules like proteins, nucleic acids, they can all dissolve in water as long as they have polar regions. And this shows water dissolving. So there's a large purple protein there, and all the water molecules are surrounding it and binding to it via hydrogen bonds. And here they are. And then that shows you how you can dissolve larger molecules in water. Okay, if a substance can dissolve in water, it is said to be hydrophilic. Okay, so hydro means water. Okay, philic is from the Greek word meaning to like or love. Okay, so if you're a bibliophile, you love books. So hydrophilic substances like water, they have affinity for water, so they can dissolve in water. If you cannot dissolve in water, you are hydrophobic. Again, hydro means water, and phobic is a fear, a phobia. Okay, so I am, as we learned in the last screencast, arachnophobic. I am afraid of spiders. So phobia is fear. Things that fear water do not have an affinity for water and do not dissolve in water. Okay, oil molecules, fats, lipids are hydrophobic because they are mostly nonpolar, so they form something more like a colloid. You don't need to know what a colloid is. Blah 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 blah. All right. So all biochemical reactions, as I mentioned in a previous screencast, have to occur in water. That's why water is essential for life. Okay. The chemical reactions depend on collisions and therefore the concentration of the solutes in that aqueous solution. So everything gets dissolved in water, and then the concentrations can depend on or dictate how fast those reactions will happen. And I think that's it. Oh, possible evolution on life, other plants without water. Okay, so obviously when we look at other planets, we look for water to support life. There are about 200 planets found outside our solar system. A couple of them have water. So Mars has been found to have water. But basically you need water to support life. So as long as we look for water, there could be life there. All right, and there's the end. Okay, see you in the next one.